Just out of show of hands, is there any electrical designers in the building, in the room? Electrical engineers? Huh, I can do whatever I want and get away with it today. Yeah, anyway, this is about the lighting module that I've been working on for some time now. It's obviously it's got some tools to help with the designer, help the designers produce the models and that sort of thing. But it's mainly to do with the back-end stuff that we're trying to get from a client side. How do we specify? How do we get some of the processes improved so we can get some consistency and improve the S constructed. But before we go into that, I've got a thing that I've got to play. It's a mandatory slide, so you got to listen to it according to. Is that working?
Time? Where'd you get this vest from? It's not yours, is it? Take it back.
Thanks for staying awake for that. I'd like to make a point on the last couple of words in there about managing the asset. Obviously, in the coming times with dollars coming down and that sort of stuff, we've got to do more with what we've been given. So part of this whole process is improving some of the stuff that we do so we can do what we need to do in managing the systems. So one of the things that we've obviously been tasked with BIM, implementing BIM for TMR. Now, this lighting package is more a project that I've undertaken as an R&D project to improve a few things for BIM implementation. Obviously, the lighting was chosen for a number of reasons. The first one will be mainly because it provides significant benefits, because as far as you'll probably be aware, we are still in the drafting space, 2D drafting. All lighting, any ITS design, all done in 2D drafting, so I think we can make significant improvements in that space. And also it's low risk in terms of dollar values compared to, you don't want to move a bridge around, oops, sort of thing. And also it's got a couple of points in there about point and linear assets at the same time. And obviously it's a big change to the electrical designers to come back into the modeling space for them. And looking in the future sort of thing, with road operations getting into more and more in the space, there's a lot of, the self-driving vehicles that comes into play. We need the assets and we need the information in the right spot. So we can't just sort of like say, oh, that thing was sort of there, and that sort of stuff. Which is, you'll probably be aware that that's probably true in some cases. So the lighting package, that was just a quick background on it. With the lighting package itself, the main objectives is to obviously clarify the handover requirements from TMR side to say, you please build this thing for us, but what do we get back? And we need to specify that in more detail. And minimize some of the hard copy drawings, manual processes that takes place, and minimize the duplication, and better manage the information that's handles around, moves around from hand to hand. And at the end of the day, it's to improve the quality and consistency of the as-built information. Now, I'd like to just mention the word information because I didn't say drawings. It's the information that we're after. I don't really care, to be honest, in what form it comes back in. So long as the information is there, we can be accurate and can rely on it. That's what we're trying to do. At the end of the day, that piece of whatever gets back to us, we need to put it into our system, and we need to manage the asset from then on. Now, if we don't have the tools and mechanisms to make it easy for us, it will get back into the same cycle of not being able to manage the asset properly. So that's the main thing. So it's to help you to help us sort of arrangement. So how do we do that? Let's just quickly look at the full life cycle. Like, to make any changes, we probably have to start from right from the start. Now, obviously, the project starts from planning and that sort of stuff, but while the project's happening, you probably want to sort of put it into a single source where the information comes through. So during planning, there's certain bits of information that's required at that stage, and the rest of it is like placeholders, so that they're required but not now. And then you go through the phases, and you collect more and more and more, and just. But the thing is, like, you're having the end in your mind, sort of thing, and goal in mind, but you're also providing the space holders, so you can specify what that is. And also it's probably good to sort of like say, here's what we need, but we can sort of like go through a gated process and ask for the relevant information at the relevant times. So at the end of the day, half or some of that information will go to the asset management system. In our case, it's the ROAMS system. But there'll be other activities that happen at the end of the finalization, DMSing, archiving, and all that sort of thing. That's project-related stuff. But from an asset management point of view, we probably won't take everything in it. We just need to know what we need to take in and keep moving forward. Now, how do we go about doing that? So the way I did that is, the first part of it is to define what we want. And the lighting schema is one of the main items, it's the core part of it. I forgot to mention that I'll be switching and swapping between the slides and probably doing a live demo at the end anyway. So the lighting schema is the core part of this whole thing. Now, if I show you a sample of it, as Lee mentioned yesterday, I would have loved to go through on IFC, but there is no IFC for us. So at the moment, we've got to start from somewhere. So gone down to defining the schema. So this is just an XML schema, so XSD file. And in it, it specifies what the rules are and all that sort of thing. So in the lighting sense, what is allowed under the point of supply, what's not allowed, what sort of values you can put in and that sort of thing. And down the bottom, it comes down to, say a switchboard, for example. You've got a bunch of attributes in there, design stage, and a bunch of attributes in the construction stage. So these are the placeholders that we need to sort of like specify, sort of thing. And on top of that, I've also gone down to part of tagging every attribute with a value. It's a carry forward from previous thing. It's more a level of detail tag, basically, more for me to sort of like say that attribute is required at that stage of the project. So for example, in the design bits, it'll be like 400s, and then for the construction part, it'll be more 500s. So I'll go through this later anyway, because this comes in hand. This is kind of utilized afterwards when we do the validation of the data. So that's the main schema there. So it's got a whole bunch of attributes, all the assets that it will require, all the attributes that's required for this to be so that we can get the design completed. And if you look at it a little, we'll go through this for now. So if we go back to the slide. Now the lighting schema, obviously, it specifies the rules, the attributes, and all that sort of thing. And the rest of them stuff is more tools. So there's tools to provide you guys so that you can help us create some of the consistency and quality that comes in. At the end of the day, the tools is kind of mainly for us, because at the end of the day, when we get the data back, we want to be able to quickly check it rather than having another person dedicated for this sort of work. And what it means, like, by the time we get to that, it'll probably be already validated. So there's a quick interface to sort of like help you create the data file in accordance with the schema. Some validation tools, so make sure that all the attributes are there and all the structure is there. And some design tools to help, to do the 3D modeling, to perform some of the electrical calcs, to generate the schematics and things like that, what the designers, the electrical designers do, and also generate some of the tables and things like that. So the modeling process, there's a bunch of ways you can do it. There's no right or wrong ways to do it. But the thing is, you got to fit it in with your processes around, because depending on the size of the project, depending on the size of your group, and what capabilities you got, you got to share that around. So what I'll do is I'll jump into this thing here. This is first time doing a live demo, so obviously the first thing you need to do is, the preferred way anyway, is you start everything in 12D. So you're getting into the modeling space, not in the drafting space. You don't want to give it to an electrical designer, get it drafted up, and here's a bunch of drawings. You go backwards and sort of like recreate the 3D from that. Why not just start in 3D directly? Now, obviously, to get the lighting design done, you need some context to say where you want to put it, and a bunch of design strings and that sort of thing. So if you've got a basin model with the information required, that's all we need. There's a macro that we run to get you started. Obviously, you need we need a surface tin so we can get the Z values out, and a bunch of parameters that where you want to put it and that sort of thing. And if you run that macro, I won't open up that new one. I'll just create a new one from scratch. This is the panel that we create. We interface with 12D. Now, on the left-hand side, you'll see a lot of where that's all the objects are created. You'll show up in there, and the order of that will be important, because that shows you, that luminaire is connected via this pit to that switchboard to that point of supply, and it gives you that hierarchy. And then on the right side, you'll get all the properties. So you've got a bunch of general information, and obviously at the moment you just start off with the point of supply, and it's got a bunch of attributes to go with it. Now, obviously, to make things easier for you, there's under the options menu, we've got default settings that you set it. So these are the bunch of objects, the individual objects that we can put in, and attributes that you can set default values to it. So point of supply, you've got a bunch of attributes to go with it. So things like your location, location probably won't matter, but things like your protection at the main point of supply end. You got your distribution cable, that's the upstream from the point of supply, and downstream from the point of supply. Same thing with switchboard. protection of the switchboard. So the more default values you set in, the less you have to go back and change things. And each one will have its own set. Yeah, so it's set up that way. So every time that's a new, if you do add a new poll, for example, it gives you whatever default set in. So it makes it easy for you down the track. So I won't go in and setting anything in there, so just cancel that. If you're doing typical route lighting, the pattern right now is, you send out the layout to an AutoCAD things, give it to the electrical designer, he'll put all the things in there, send it back to you. Now, I'm trying to eliminate that process by saying, why don't you just put it straight in there? So basically, if you're going to doing a route lighting, route calculations, you probably will start off with that panel. Same thing, same information that you'll require when you're doing your lighting in AutoCAD stuff, where you want to put it, what spacings and that sort of thing, what luminaire types. And Brendan's helped me with this part of it, actually most part of it in here. I just did the electrical bit. So the first thing is like set your reference string, and your left and right, if you got left and right arrangements. Hopefully there won't be any errors popping up. By the way, this is all working in progress at the moment as well, because I've changed a few things that Brendan's not aware of yet. So yeah, and then you just set this is all the typical stuff that you put in for route lighting, what tariff it is, rate 2, rate 1, rate 3, luminaire code, arrangement, left, right, opposite, staggered, whatever, so just go opposite, and all that sort of business. And then down here, the information that you would have got after you ran your route lighting calculations in Perfect Light, AGI, whatever. Yeah, so I'll just start with 4,000 and create. Now you probably will see in a few seconds that I create it. I did create, yep. You've got a bunch of luminaires created, sort of thing. But the way it's set up is in electrical sense. There is you can't just put a pole on its own. You've got to put, the way the TMR spec says is, every time you put a pole, you need to put a pit next to it in this arrangement. And in the pit, you've got a bell joint, and in the bell joint, there's a cable that comes out into that. So every time there's a change in cable sizes, you've got to create a circuit. That defines what the cable drop size is. And whatever default that you set in, it just creates that for you. Now, you'll probably see this point popping up here. It just shows you where the things are created, but until you see what it is, to quickly get your view on it, you can just go and model it. And obviously it gives you the option that say, error message saying point of supply location's not set. That's fine. And what it does is it quickly goes and places your things in directly into the model. Now, and then, once you're in there, okay, all right, let's set this, say the location side of things. Okay, that pole doesn't fit there because there's a culvert in there or whatever, sort of thing. And to move things, it's just fairly straightforward. Just go and get it. Which one did I show? So I just moved that pole. What did I move? Moved the point of supply. So let's move that one back again. Put the point of supply there, and say that pole there, which is that pole there. That shows up in the marker thing. If you want to move it, just go into location, get point and rotation to get the alignment, the angle of the luminaire. So if you say, for example, just for the sake of this, it moved it, and then you go about and doing all that sort of thing. So the main data source is inside this panel here, which is the XML file that's been saved behind the scenes. And all the attributes are there because you've set it. Now, once you set that there, and when you're happy with it, when you're happy with it. You probably want to do your luminaire things. What did I do? Sorry, I'm not really an expert 12D user. Did I say escape? Yep. And what it does is it places the contours when it finishes. It places the contours for your lighting design. So you can do everything in here directly without going out into the drafting space. Now, once you're happy with it, just go, I'll just get this out of the way. Now, once you're happy with the lighting design part, then you can start looking at, okay, what do I do with the connections, the electrical connections? Now, the electrical connections is fairly straightforward because you're not playing with drafting now, you're just playing with moving objects here and there in the panel. So obviously the pointer supply is over there, and I need a switchboard underneath it. So these are all context sensitive menus. So when you do a right click and you say new, it only allows what is allowed by what the schema definition says. So underneath the schema, you need underneath the switchboard, let's say we need a circuit to create underneath it, and another circuit below that one. And let's say we put one row of luminaires on one circuit and the other luminaire on the other circuit. All you have to do is just drag one of them, drop it in here, and child to that one, and the opposite one underneath that, and so forth. So should have just done a little bit. So that gives you the structure now, the connection things. Now, okay, let's, I forgot to put because from the pointer supply, you need to go down to a pit to a switchboard. Okay, let's put one in there. So I'll just go to a new pit from a switchboard above thing. And I'll set the location, I'll set the location of that one to say somewhere here. And obviously the main cable that runs from the pointer supply, the structure here, the main cable that runs from the pointer supply runs through this pit so if you look at it from a child-parent relationship, main cable runs through the child, loops in, loops out, runs to the child, loops in, loops out, runs to the next child, which is nothing there. But once it comes to the switchboard, there's another set of cables that because the circuit will be a change in the cable, and that cable runs from that descendant node in and out, loop in and out, loop in and out, loop in and out. And then the same thing, from the pit, it branches off and forms another circuit and goes into the pole. Now, that's the way, and then the thing is for this case here, if you have a switchboard, the pit that's intermediate to the pole, so when the main cable runs from pointer supply through that pit, through that switchboard, obviously anything that coming from the switchboard needs to come back through the same pit. Now you don't want to create a new pit every single time and duplicate things. So what you do is just do a copy of that, and it'll copy the instance of it, but more like a reference, and you paste it above. Now that pit and that pit are the exact same pit. So if you look at the ID, 11, and that's the 11 too. So the same thing in here. So if you do a copy of this item, and you go down here and paste above that. And once you're all good with it, just go and, actually I didn't put the switchboard location. So get point. And once you're happy with it, run the thing. and it'll have moved everything for you. So, oops, what did I do that for? So this is what I wanted. So point of supply to that pit, to the switchboard, and from the switchboard comes out here to the back to the same pit, runs to this other pit that was connected to this pole, and then runs that way, and then the other circuit runs down that path. Now all that's done for you, and the beauty of it is while this is happening in the 3D space, you also got the poles created for you. And wherever the point of supply was, pole there, and the switchboard there. And back again. And I'll do it slowly this time. Oh yeah, that's the thing, yeah. Oh, I was hoping no one picked that up. And all your underground stuff as well. So I didn't go and do a, I should have done this other one too. So if you go in and do a model with ducting, it takes a little bit longer, but basically it creates the ducting between the objects that you created. So all that is done for you. Now the beauty of all that thing is like now you've taken the drafting into the modeling space in terms of attributing and that sort of stuff. And at the end of the day, one of the other benefits is because the data is now stored in a structured format, we can validate it, we can do the electrical calcs, we can write scripts to do all that, get tables out, whatever you want it, in certain order, like quantities and that sort of thing. So when this finishes, quickly, and obviously like while it's happening, that was the route lighting run. For intersection lighting run, you just add a pole, put that in, add a pole, put that in, and do the normal luminaire calculations and the lighting contours, and get your lighting sorted out. And the same pattern applies. Do your lighting electrical connections at the end. Now this is what I meant. So all your ducting is done, and obviously Brendan had a bit more time on his hand. So he put a marker tape in there. So, so just don't forget to put that in. So yeah, that's the modeling side of things. And now that you've got all that, now your schematics, for example, is part of the tools because the data is now structured. Where's this thing? I think it's this one here. Yeah, there you go. So that schematics is now done for you. So it starts with the point of supply, your fuse that you provided, the main protection, your cabling runs through that pit, runs through that switchboard, runs through, all that sort of thing is now generated because you got the data structured in a format. And, basically that sort of thing. And this is just my labeling, color coding and that sort of thing, but that can change. It's very easy to change just a config file. Basically it says, that pole there runs off phase A, if it was phase B, it'll run off the phase B and that sort of thing. And the thing that, from an electrical point of view, is concerned, is the electrical engineer needs to RPEQ it. The calculation that applies to him would be under that menu, which I'm running out of real estate here. So that calculation is now done for you. Obviously the header stuff, all your default values, your slack cables that you put in, and the main calculation part of it, which this is the upstream calculations from the transformer down to the point of supply, and point of supply down to switchboard. So this is the worst case load calculations, which they do now, and then it'll calculate all those values for you. So now that's done for you. The electrical engineer or whoever's RPEQing it will need to verify that, make sure everything's right. Now, then just so I could do it, where is that gone? Oh, there you go. You can also do the detailed version of that, which jumps down everything in there. So this is the whole lot of calculation, because now the calculation is there, the script is there, it's just calculating it. So it's no extra effort required to do this now. Whereas now, like if it was doing it in drafting, if you change something, someone's got to go back and do that piece of work, which is a saving time. And the one that I was going to show at the end is, now that you've done that, there's validate option there, because when the data comes back to us, we want to know, is everything there? And when it finishes running the validation, it will say, hey, where's my owner? Where's my that? Because you've asked for certain things. Now, remember where I was talking to you about tagging each element attribute? Now, if I set that value in the general thing to say 400, and when I do a validate of that data file, I'm looking for everything that's tagged 400 and below to be there. Now, if it's not there, then it'll come up with, where is it? And it's not in the right spot. So, sort of thing. Yep. And so that, and then there's obviously if you set it to 500, you ask for certain things, extra things in there. Just a quick wrap up. Obviously the same thing. If you don't have a design tin and that sort of thing, area photograph draped onto a tin or a flat surface will do just the same thing. So placing in our locations. So this is projects where civil works is not usually part of the lighting design. So that was pretty much what I had. So what's next in there? Obviously I've got up to the design stage. Need to get the construction and finalization attributes. And the other thing that I would like to do is expand the schema to cater for all the other ITS and electrical assets. So it's all contained in the one discipline. One thing maybe for Lee and the others is how do we get this model now out on the field to collect certain attributes while on field? Now, surveyors are not the only one that's going out to collect some of the attributes. There's electrical inspectors, there's whoever needs to go out collecting other bits in there. So they need to be aware of tools so that they can put directly into the system and obviously link some of those reports that they put in with DMS system that we got in place. And the last thing, I'm sort of like just more like a memory jogger anyway. How do we integrate that with the IFC 5? That's probably coming. At the moment, I'm not sure, but I don't want to sort of like carry on a different path when there's a standard already available. If we can sort of like integrate, migrate, I'll prefer that, but if it's not, then we'll just go with what we got. That's all I have. If there's any questions, please let me know afterwards. And yeah, thank you.